All right, let's talk cloud security, but let's forget the boring technical manuals for a minute. Today, we're going to build something, a blueprint for your very own digital fortress. And this is all about a mindset, a strategic way of thinking about defense.
I mean, it's the question that keeps a lot of us up at night, right? You've got threats coming from every direction, all the time. So how in the world do you actually protect the stuff that really matters? Your data, your apps, when they're living in the cloud? Well, the answer isn't to just build a taller wall. Nope. You have to think bigger. You've got to build a fortress, one with layers, with depth, with some real intelligence built right in. And that's exactly what we're going to lay out for you today. Okay, so first things first. Let's start with what is probably the single most important mindset shift in all of modern security. Ready? Assume a breach. Yeah. Assume the bad guys are already inside, or that they will get inside. This changes everything. Suddenly, defense isn't just about the front gate anymore. It's about what happens after they're inside. It's all about containment. So if we're assuming they're already in, how do we build for that? Well, it all boils down to 3 core strategies, 3 big moves. First, we segment. We chop our network up into smaller, isolated zones. Then we filter. We check every single thing that tries to move between those zones. And finally, we can even transform data at the boundary to make it harder to understand. Let's see how this works in practice. All right, layer 1, securing the perimeter. Think of these as the big, high, strong outer walls of your fortress. This is your first line of defense, where you meet all the chaos coming in from the public internet. Now, the techie term for this is north-south traffic. Don't let that throw you off. It's just a simple way of describing any data that's flowing between your trusted network, your good stuff, and the great big outside world. It's literally all the traffic trying to get in or out of your main gate. And you gotta remember, that gate swings both ways. You've got ingress, that's all the traffic trying to get in, and you've got egress, that's everything trying to get out. A really good fortress watches both doors, right? Because a threat can try to break in, but a compromised machine inside might also try to sneak data out. So who are our gatekeepers at these walls? There are firewalls, specifically our edge firewalls. You've got your general purpose ones like an Azure firewall that can look at all kinds of traffic, HTTP, RDP, you name it. But, and this is key, for your web applications, you really need a specialist, and that's your web application firewall, or WAF. It's designed to understand and block all those nasty web-specific attacks, like SQL injection, right at the gate. And right here, you've got a pretty important decision to make. Do you use the native tools that your cloud provider gives you? They're usually cheaper and, they integrate perfectly. Or do you go out and get a third-party solution from the marketplace? These can have some really advanced features for sophisticated attacks, but they often come with more complexity and a bigger price tag. It's a classic trade-off. Okay, one last thing for our outer walls. What happens when the attack isn't clever, it's just brute force? I'm talking about a massive flood of traffic, just trying to batter down your front gate until it breaks. That's a DDoS attack. The good news is most cloud platforms like Azure have built-in protection for this. They can absorb these huge waves of traffic so your application never even feels the hit. Okay, so our outer walls are looking pretty solid. But remember that mindset. Assume a breach. So let's say an attacker does get past the outer wall. What now? Well, now it's all about the internal defenses, the internal walls, the moats, and the checkpoints. This kind of internal traffic has a name too, east-west traffic. This is all the chatter happening inside your fortress walls. Think of it as the communication between your web servers and your databases, for instance. And if you're assuming a breach, controlling this movement is absolutely critical. You can't let an attacker just wander around freely once they're inside. So, what's the big strategy here? It's called segmentation. It's so simple, yet so powerful. You wouldn't build a fortress with just one big open field inside, would you? Of course not. You'd build internal walls, different sections, locked doors. In the cloud, we do the exact same thing by carving up our big virtual network into smaller, isolated compartments called subnets. And at the doorway of every single one of these compartments, we post a guard. In the cloud, these guards are called network security groups, or NSGs. Just think of them as mini firewalls for each little area. They're super strict. They check every request based on a 5-point checklist: protocol, source IP, source port, destination IP, and destination port. If it's not on the approved list, you're not getting in. Simple as that. Okay, now we're going to the deepest layer. We've got the outer walls, we've got the internal checkpoints. Now, it's time to secure the crown jewels. We're talking about putting guards right on the door of the most critical things in our entire digital kingdom. So when you think about your most valuable assets, say your main database, you're faced with a really basic but critical choice. Do you give it a public address, meaning it's technically reachable from the big, scary internet? Or do you make it completely private, totally hidden from the outside world, and only accessible from inside your own secure network? So how do you pull that off? How do you make something just disappear from the internet? The answer is this amazing feature called a private endpoint. What it does is it gives that cloud service, like your database, a private IP address that only exists inside your own network. It's like giving it an invisibility cloak. To the public internet, it simply doesn't exist. And the benefits here are just huge. I mean, think about it. The service can't be attacked from the internet because, from the internet's perspective, it's not even there. All the communication to it is happening over a totally private, secure channel. And here's a great bonus. It also locks down outbound traffic on that port, which makes it way, way harder for a hacker to steal your data. This, right here, is what defense in depth is all about. All right, so we've built our outer walls, we've set up our internal checkpoints, and we've locked away our crown jewels in secure vaults. Now, let's just take a step back and look at how this whole thing comes together as one unified strategy. And there it is, your digital fortress, fully built. You've got your firewalls and WAFs as the high outer walls. You've got your virtual networks and subnets acting as the internal walls, creating all those different compartments. You've got NSGs standing guard at every single checkpoint. And for the grand finale, you've private endpoints acting as the final impenetrable vault. It all works together. Look, if there's only one thing you remember from all of this, please let it be this. There is no silver bullet in security. There's no one product you can buy that just solves it. Real effective defense is a strategy. It's about designing these overlapping, layered controls at every single level of your system. And that kind of leads to the final big question, doesn't it? We've just spent all this time designing the perfect technological fortress, but any fortress is only as strong as the people and the processes inside it. So as we build these incredibly secure walls, how do we make sure that our human processes are just as secure? That's the next big challenge, something for you to think about.